We have the major ZK projects here today on the stage. It's really important for Singapore because this network has been some, frontier ZK topics and panel here. It's our honor to have all you guys here. The first question today is about the discussion about the security of ZK circuits. Actually, I asked the question to Vitalik last week in NTU about the security of ZK circuits. Because the ZK circuit is getting more and more complex, and so we have a lot of concerns about the security of ZK circuits. We can see that a lot of mainnets is going to be alive in the next season. What do you guys think about the security of ZK circuits? How do we ensure that the circuits are secure, and how can we help the auditors to audit the ZK circuits? I think Alex, you can go first.
I'm going to start from your vision. My observation is that circuits of ZK-ADM is what we use in VDC. The tendency is that they are getting simpler, not more complex. Previously, as we were building ZK thermal electric systems, we would have to write all the circuits from scratch manually. Now we are building universal, reusable blocks that are very similar in their functionality, and then we combine them together. And the overall complexity of ZK-ADM is arguably lower than the complexity of something like optimistic Prologs. So the future we envision is that people will not have to write circuits manually themselves. It will be a task reserved for a small group of cryptographers and professionals with a few universal stacks that are having a lot of eyes on them and a lot of audits, and everyone else is just going to be writing the normal code in languages like Solid or Rust or C++. They will compile to some virtual machines that will be executed on these universal processors, and this way people will not have to worry about making technical mistakes, really understanding the nuances of math and cryptography.
Yes, the security is clearly one of the topics, main concerns. In Polygon, we were, very active in the audits and this, model of certifying to users as the circuit have been reviewed. I agree with Alex that every time we have more experience, we tend to simplify. Initial versions were more intended to prove that such a system is feasible, that's practical. But now, every time we have more experience, we are trying to simplify more and more these implementations. We call the organization part for ZK-ADM to match this EVM equivalence, and also the proving side. So this is a very emerging technology. At this point, we are basically starting. So this security in Polygon, we have also bug bounties. We are receiving a lot of issues from contributors from the community. Nothing was critical so far, but this experience we are getting with third-party participation and contributions is also very important.
Cool. I think most software still have bugs. It depends on your definition of complexity. I think circuits, due to the lack of tooling and shared best practices, I still think it's quite hard to claim the ZK is secure. At least from Tiger's perspective, we don't want to claim our circuits bug-free and secure. So that's why when we design our protocol, we always assume we can only trust circuit in theory, but from an implementation perspective, it will take years. So we embrace this multi-proof concept where one single prover can say, okay, I prove this block with a ZK, but I place a bond or deposit there, and you can challenge me. And once challenged, you can ask another prover to provide a more secure, a stronger ZK proof using another set or more than one set of circuits. So that's our approach. We always feel like we need to take care of the security more with more care rather than just claim something. I really believe in ZK in the long run will be more secure, but not in 2 years.
I think from our perspective, So there are many different directions. When you're talking about ZKVM security, I'm thinking about like you worry about ZKVM security because you worry about the security of a ROC. So we take multiple approaches, not only like we can enhance the security of ZKVM, but also our system. For example, like we spend we can like spend millions of dollars, like we the best auditing, contracting with the best auditing company, and we co-host some kind of security workshop with Polygon to kind of teach auditors like how different like ZKVM are designed, and then we share experience of what bugs defining your system and what bug defining our system. And also because I believe in Linux not law, which means like if your code base is open source for a long time, then like there will be like the risk of having bugs in your code base is minimized. So that's why like all our ZKVM circuit code base is open source from day one, and any contributor can contribute, and there are actually a bunch of really great external contributors contributing to the repo, and which really like lower the security of our ZKVM circuits. And I think we are also giving some grant to some kind of circuit auditing companies to start doing some like following for your ZKVM like outputs and all those kind of stuff, kind of further enhancing the security. But I agree that with Daniel that there is no like bug-free ZKVM for quite a long time. But it doesn't influence the ZKVM security because your sequencer will generate log, generate stateful, and everything. Query is just more like a checker. That's why you kind of not directly giving the power of proof generation to external parties and they can suddenly proof, then it's totally fine. And also we are also working on some multi-proof direction. And but in general for ZK like circuit security, there are also some other direction which I don't know whether it's promising, but I just mentioned here that maybe eventually when people care about security, because people are still talking about performance a lot more than security. And so one day, like when ZK is really performing enough, people really start to care about ZK security. Maybe like there need to be some kind of front end or circuit language designed for verification or some other way, like which means that you write packet-free circuit. So that might become a direction, but we're still very far from it.
Great. I think we got some great questions like multi-prover, like compiler, better language. So I want to build on these answers. So I think another important thing is we want to educate more people to get familiar with ZK, and we want to build a larger community. So, for example, if you look at the Linux operating system, they always have bugs, but thanks to the community is so large, people can always find the bug, fix it in time, so that the Linux becomes the most reliable system. So we want to educate more people to learn what is ZK, and in this case, we want more people can look at our code, and more people can find more bugs, and we can fix it faster. Yeah.
I mean, I think from our perspective, like we are more focused on use case level of ZK. So the idea from our side with security is like more on the user facing side, and the way what we are thinking is like to make circuit more security is trying out to write very big circuits, because I mean we can actually write small circuits to achieve some features. So like that's actually different ways all the ZK put the whole EVM into circuit. So on the privacy use case, on the like credential use cases, on the like gaming use cases, they're more like have different like small circuits. So that actually makes things easier to build and to like audit. And but another thing what we are doing is we need to abstract the existing circuits into contract. So there's also facing a lot of contract risk, and that's something I'm extremely careful these days. How to like work on both and ensure the whole like application is secure.
All right, thanks. Actually, lots of professors and university are actively looking at the security of ZK. And just now, Professor Liu Yang from NTU, he told me that they are working on some form of verification research on the ZK circuits. So I think you guys can also take a look and collaborate with them. So yeah, the second question goes to the ZK proof acceleration, and we know that ZK comes with a lot of costs of requiring substantial resources to generate proofs. So and we also have observed some optimization aimed at addressing the concern, such as using smaller fields at the proof system level, or employing hardware like FPGAs and the CPUs to accelerate the proof generation process. So how do you guys approach tackling this challenge? How do you accelerate the ZK proof? Alex, okay, you can also go first.
Sure. Okay. Here's me again. The proof systems that we're using today are already quite optimal. Like what we use at ZK-Sync is a proof system based on Starks called BootJob. The amortized cost per transaction is quite negligible. It's just a fraction of a cent because you can run the proof generation in parallel on many different GPUs. The GPUs are optimized for maximum distribution with a very small footprint of memory and resources required. So we're already in a very good range with regard to use cases such as DeFi or like whatever we have in blockchains. But of course, I anticipate that we're far from falsifying the proof systems, and they will change in the next couple of years. And you just have to be ready and embrace the new technology as it emerges.
So yes, I agree with Alex. The cost today is kind of negligible. This argument of this cost of proofs was used by Felix Technologies some time ago, and the cooling systems in production they are not expensive. I mean, for us, probably proving an Ethereum transfer is 10 to the minus $4 in cost of proofs. So it's nothing compared to the data availability as of today. So it's we're waiting for EAP 4844 to improve that cost. This is the biggest part of it. The proofs are not the differential between optimistic rollups and secret rollups as of today. We have announced recently the initiative to upgrade the current Polygon POS to ZK Vanadium, and our estimations are that we can just easily cover that. So this means that I think, of course, efforts in acceleration are important because many applications can be benefit from that. In our side, we have been investing heavily on GPU acceleration, FPGA, but our bet completely is standard hardware, the common hardware, because we have a lot of research in Bloom 2 and now Bloom 3, and we believe that it depends on implementation. Some hardware application may be more or less suitable, but as of today, cost as a driver of decisions, I think is not a relevant value.
So here, I think we also have people working on optimization, but mainly on CPU optimization. This is not our primary focus. I believe we have better team who can do that, or we can just benefit from those efforts. I think in general, at least there will be like 3 different approaches. The first one is, of course, just optimize the circuit and optimize the underlying proving backend, and then maybe some software use like FPGA or a CPU vendor. A second approach may be design specific hardware to accelerate proof generation, and maybe a third one will be like you just break down the work into smaller chunks, and you allow a really low-end computer to work on these chunks and distributed way, and then you aggregate all together. So basically, you try to use the idle resources out there, like home computers, to generate those proofs. Because it's the ZK rollup is not a POW system, right? You don't really need a lot of computation power. If you can, for example, if you can have 1 block per second, and a year later, every proof takes just like 15 minutes to generate, and you just need to have like less than 1,000 machines, right? So you don't really need a lot of power to secure the chain, keep the chain alive. So Yeah, okay, so technically we don't have a lot of engineers working optimization, but we look forward to work with other people and to try to use their technology to, to accelerate our proof generation.
For us, like we do have people working on GPU implementation, and we can already accelerate the Halo 2 stack for maybe 10 times faster, and we already apply some really optimized FFT algorithm to really lower the GPU memory requirement. I think it's already like 8 gigabytes like GPU memory requirement for running a prover, but the CPU memory requirement is still high. So that's our next optimization target, but we are confident to further lower the cost to become like 5 to 10 times faster. But again, like this ZK performance is still not the biggest bottleneck of the ROP system, because I mentioned like you only need to generate proof once, but you need to consider like when you incentivize like how much redundancy you need to pay to those kind of redundant prover, avoid single point failure. But that's further down the map. I think when you're talking about ZK performance, it really goes back to some trade-offs, because you can always cut the computation to be smaller one, run on very cheap like machines, and then but your proving time might be like 1 hour, 2 hours. And even if you have really amazing fast prover like 2 minutes, 1 minute or whatever, like you still need to wait for enough transaction to fill up the trunks, and then like in some the tool, maybe that already takes like 30 minutes. So it's all trade-offs. Currently, we are in a really good stage of like our proof generation is fast enough, but we are still working on like the system and how we kind of like do this recursion and for a block, and to kind of further lower the cost. But currently, it's already very optimal.
Yeah, we tackle this problem using our algorithm. So in our new algorithm, it's already very efficient. Like we can prove like 1 billion size circuit within several seconds, and the total power draw is about 0.001 kilowatt hour. So if you imagine that you want to decentralize our system, and if you have like hundreds of machines running in a network, and for a single proof, the total power draw will be less than 1 kilowatt hour. That's a pretty low cost already for us. Yeah.
Yeah, I'm actually like thinking the same way as Tiancheng. We are more focused on application level ZK, so the circuit won't be really big, and the proof generation actually much easier than ZK. And we actually in the beginning the proof generation is in the desktop, so you have to download Signer, and it takes like 40 seconds in the beginning. I remember the first version Signer to actually do the proof generation. But we do a lot of optimization, like use Poseidon hash and keep working on things included in there's GPrice. I remember last year, work on different stuff and make it to like 2 to 4 seconds, and we deprecate Signer into wallet and make proof generation on browser. So it's still in local, and right now it still works. But I do think, we are also actively talk to Scientific. I know ABC Invest, those guys, they're really smart and brilliant team. And I think, if there's really huge demand on the use case side, there's very big adoption. Let's say millions or billions of ZK generated at the same time. It's actually need hardware. To do the proof generation other than I think desktop, and also I think for the infra level, I'm actually recently learned from Polygon about share prover, and I think this is something really interesting. It's also potentially a solution to lower the cost besides
Yeah, cool. As Victor mentioned, we are going to launch a ZK illustration DAO with ISIC, which is the top ZK illustration hardware company, and we are going to provide ZK acceleration service for all kinds of ZK company and projects. We have talked to Scroll, Taiko, Polyhedra, Manta, and we will provide ZK acceleration power for them. We actually have already have 2,000 4090 GPUs to accelerate all kinds of ZK boosts. So yeah, we want to use this power to support more and more ZK projects. Yeah, so here comes the third questions regarding of ZK layer tools. We have 4 major ZK layer tools here today: ZK Sync, Polyhedra ZK RAM, and Taiko and Scroll. So how do you build the difference between each other and your competitive landscape? And what will the layer 2 be like in the future? Do you think that's going to be more and more ZK layer tools? And it seems like the layer tools are going to be more and more competitive. Yeah, I think.
Start with this.
Okay. Yeah, you can go first.
I think from my view, like, because currently there are different routes launching services, launching stacks or whatever. But I think from our perspective, we know, like, how difficult it is to operate a chain. So I don't really believe that there will be so many really secure ZK layer tools coming on, because no one here maybe like is confident enough to say like our circuit is bug free. And then if you allow like so many people using your code and to launch their own layer 2, that will be very dangerous. So that's why like we are kind of until the point that we are confident that we are super secure, we want to encourage like especially smaller team like why they want to kind of launch their own ZK layer, because it's really costly to operate, and also it's just you don't get enough security guarantees. And in terms of other like like different like I'm trying to avoid like different type of EVM, because it's actually a more intuitive way, just EVM equivalent, like where you can prove layer 1 block, and EVM equivalent, which means you can prove bytecode level compatibility, and like language level, which means you can prove solidity. So I think currently we are in a stage of the middle stage, because we believe that we want to launch a really product ready, secure first, and fully audited, and also performant enough ZK EVM, and that's the best middle option. But at the same time, like we are also contributing to kind of building a really EVM equivalent ZK for EVM. We believe that's a long-term goal, which EVM will eventually apply this goal to kind of maybe upgrade during its roadmap to ensure itself. Or we are always like the large contributor to that effort. And but we just don't see like it's performant enough right now to kind of really apply that stuff. And also like we think like launching something product ready first is it will be beneficial. And in terms of other like ZK VM compared with ZK VM, I think like they are with zero running some kind of RISC-V based like ZK virtual machine, which can also run gas on some other code. But I think it's very hard for those ZK virtual machine to have specific optimizations to certain parameters like EVM path, like catch track, and all those stuff. Like you need some customized design to embed to kind of optimize those special optimize. I think ZK VM is already a special enough system to have its own inventation, not just like using a general way to kind of adapt this. Maybe on that front you can provide some other smaller ROS application, but ZK VM is important enough to influence the roadmap for VM. So I don't think like using that approach is really the best and the most optimal way. Yeah, that's compared with ZK. And also like there are some people already deploying like Bonsai, which is like RISC-V with like testnet and on Scroll. So if you can deploy that type of ZK VM and Scroll layer 3. But at the layer 2, what we want is just to like cheaper the EVM block space, making the migration become as easy as possible and reduce the fees, not adding too many sensitive features, because that's the initial starting point for why we want to have a layer 2. For everything else, we support pairing, we pre-compile, we support a lot of pre-compile, just come to deploy layer 3.
Cool. Daniel, how do you think about it?
I think it's extremely lucky for us to work with really smart people in scalability. I think all the layer 2s together, we help Ethereum. We try different approaches to scale Ethereum, and the result is after many years, maybe one or two approaches will eventually prevail, and this is the way to scale, right? So we learn from each other, and as an ecosystem, it's more like it's less risky because if you compare with compare Ethereum with like Polkadot, their interchain protocol is like fixed, right? And with Ethereum, we can all opt in different protocol design. So it's a really powerful ecosystem approach to scale this chain altogether. And we are trying to learn from each other. I think we share the ultimate goal. The goal is to scale Ethereum and in meanwhile provide a really nice developer experience, right? I think from layer 2's perspective, we see things a little bit differently here. So we really encourage people to deploy their own layer 2s because we believe some actions may have really low expectations about security. They're okay with like optimistic rollouts, right? If you look at all the popular chains with a lot of users, they are OP chains right now, right? A lot of them are OP chains because people really don't care, especially with low value transactions. We sometimes overemphasize on the security aspect of a chain, but people really care about user experience. So that's something ZK rollouts will have to catch up to make sure we offer even a better user experience than OPs, right? So a lot of things that we need to work together.
Sure, agree with that. ZK will need to catch up with OPs. How about you, Gabe?
I totally agree with what they said. I think you put together in this panel very, very good teams that we respect a lot each other. These teams are building the non-malware proposition. Maybe there will be more teams, but as also they said, it's not the same thing to run a production report than do some kind of niche research. So it's again, I think we are in this phase where there's a lot of exploration of different alternatives. There's a lot of research and ideas. At some point, as also said, this company many other aspects of the IT industry, there will be a final convergence as some of the solutions prove better. But the idea is that these user value propositions might differ in some way, and different use cases might use different levels. So any other project that wants to propose or wants to build, I don't think we are specifically concerned. Because today we have these optimistic rollups that they were considered kind of a temporary solution. They are getting a lot of market as of today. We were discussing before about security of CK secrets, and it's kind of funny that some of these projects don't even have proofs. So, as he also said, security is not a concern. It never matters until it matters. So, we need to see how these things evolve, because layer 2 is now flourishing heavily, but at some point we will see. And it's also good that we are working in this open source world. We contribute with ideas, with exploration. Some things are coming, but we are open to improve, collaborate, and this is what the spaces are for. We want to repeat and inherit these Ethereum values into this layer 2, so we can just provide to the users the same level of security, centralization, and provide the scalability part. So that's the spirit we are building after all of us together.
I fully agree with the spirit here. We're in a phase of experimentation. We're building on top of each other's ideas. It's going to be a while to figure out the right solution. I think technologically, at the level of virtual machines, that the APIs, what the stacks can provide, we will all converge eventually to something very similar. We probably will be able to have same standards and people will be able to do operations. So I want to focus more on what is the area that we're exploring differently, where we're focused. For ZK, it's this idea, we've been, for the past 5 years, we have been an extremely mission-driven project. Everything we've done has been judged against the North Star of the mission. We recently formalized this North Star in the form of the ZK Credit Manifesto, where we outlined very specific, very concrete values that the project orients against and that we want to see built in the long run. Like the end game for scaling blockchains overall, but I highly encourage you guys to take a look at this. And for us, the focus is on achieving this end game. Like, what do we need to do to get mass adoption of Ethereum overall? Everyone, imagine a world where everyone has a mobile phone in their pocket which has connection to internet, and you have your Ethereum wallet that is super easy to use, fully affordable, you pay like less than a fraction of a cent for every transaction, and nonetheless it scales to arbitrary number of people. So what are the technological choices, the architectures, the topology of a network that will take us to this future? So this is something we explore with ZK Sync a lot. This is we call this property hyperscalability, and this is the architecture of the ZK stack that we emphasize and we want to see developed in the first place.
Yeah, sure. I totally agree. Actually, I think all the ZK layer tools here today share the same goal to get Ethereum to massive adoption. So I think that's the same goal. And in terms of the liquidity, I want to talk about liquidity. So we know that there are more and more ZK layer tools and more layer tools. And so the liquidity is getting like isolated. And actually, we know that most of the layer tools are doing scalability. And we have Polyhedra and Manta here today, which are using ZK to do interoperability. So I want to have Tiancheng and Victor to talk about how do you guys plan to use ZK to do interoperability and bridge the liquidity together in Ethereum rather than isolating them. Tiancheng, you can talk about.
I think so. For our ZK technology to use in the interoperability, it's more like proving their consensus is correct, and then we can say we can correctly validate any transaction inside about that specific blockchain. And the liquidity pool, we are collaborating with Layer 0 to use their liquidity solution, so we can serve as an underlying communication protocol for any liquidity pool. So we can bridge the Ethereum to any other blockchains using their own community signature. So in this case, there will be like more than 32 billion of this totally staked Ethereum compared to other solutions, because we are using the whole validated set of Ethereum. So this huge amount of money will secure the protocol as well as the liquidity, so we can pretty much safely use it. Yeah.
Yeah, I mean, I think from our side, we really practical, and we are actually, really for the first one, the first layer tool using Celestia SDA. So I mean, from that level, on the modular side, all of the Celestia, DA projects, they can actually talk to each other. That's another level of interoperability. And from another level is we actually on the rollup side, we are really practical right now. On the first stage, we just use OP stack, and then on the OP side, all of these OP stack projects can talk to each other. But I mean, the end goal, we also thinking how to get ZK prover, how to get server multi-prover and then ZK prover, and maybe can talk to other share prover projects together. And also on the break side, we got work with Polyhedra and get liquidity from Layer 0 and Polyhedra to make the application level assets more secure and installable. And on the credential side, that's another level. We actually enable the credential minted on even our previous Polkadot parachain actually use through proof key. That's what we generate the proof key to use in any other chain. They just use an API to verify it, so you don't need to actually connect all these switch to different chain and to achieve the identity verification. That's another level of interoperability.
Okay, so Ye and Dave and Alex, you guys have any idea how to solve the problem of the isolated liquidity in layer 2s?
Well, we have announced lately this vision of Polygon 2.0, where we envision this unified liquidity model, where we are leveraging on CK proofs to interconnect these different networks. So we can have a model of composability between chains with a fast execution. Of course, we can do something right now with using our shared bridge, but this layer has to be built. It's a recursive proof generation model, but we have this plan as of today, and this is the vision we have. It's only working for our tech as of today, but we could do this as a standalone framework and system to other chains. And it's not something that we want to build as proprietary for Polygon, but to layer unified. But this requires CK proofs, of course, because we need to have these stability proofs and this fast finality. Otherwise, this says models of security of this network needs to be absolutely certified. If not, you will be compromising. One network security will be compromising the rest of the system. So we want to extend this use of CK proofs to provide somewhat a layer of interoperability.
Okay, cool.
And so again, I can add that we have a very similar model at ZK-Sync network called the Hyperchain. So every hyperchain will connect to hyper bridges, and there is a very interesting technological barrier to extending this model outside of a single network. Like within ZK-Sync, we can have hyperchains connected seamlessly. They can be operated by different parties. They can be completely decentralized. You don't have to run all the validators of all the hyperchains, but they still can connect in a way email connects today. You can send a message from any address at any domain to any other address from any other domain. It will be extremely hard to extend it to make it like a ZK-Sync hyperchain interoperate with a Polygon supernet or with some other law for two reasons. One is the liquidity is actually locked in the smart contract on Ethereum. So in order for us to pass some amount of funds from one hyperchain to one supernet from between the networks, we will need to move this liquidity on the underlying layer 1 contracts. That will incur layer 1 costs. The second problem is that you have to be able to trust the messages that are coming from another network. So unless you share the circuits, unless the other network uses exactly the same zero knowledge proofs as your network, it's hard to trust because you don't know who is controlling it, how they can be operated and so on. So for now, I don't really see how we can extend that. And therefore, I think what we will end up with is going to be a small number of these big networks that accrue network effects into them that are harder to interoperate between, but still easier to interoperate if we're all on Ethereum, so we can always use layer 1 to pass messages and pass state and pass liquidity between them. It will just incur more cost. But this cost is going to be much less, and with much less cross-assumption than, say, transacting from Ethereum to something like Solana or Bitcoin. So you have these different degrees of proximity between chains, and this is going to be the case, I think, for a while. I don't foresee the generic solution. Unless we enshrine some things in place protocol into Ethereum itself at some point.
Okay, cool.
And for us, we are not really making this become a high priority, and also I don't see a really great solution for solving this kind of liquidity fragmentation. I'm quite honest about that. I think using ZK has some advantage where because all the ZK are putting in the same state on the same base pair, which means you have some possibility to read from the other layer to in a more trustless way. But this might introduce some latency. And also when you mentioned liquidity sharing, there are different ways. it might differ per application. Like there is some way for legal to share, there's some way for liable to share. It's very hard to say that you find some very universal solution to how to share all the liquidity across all the particles, or you might based on some economic assumptions, which might bring some secure assumption. So that's why it's not our priority. But I do see some possibility, like maybe some data rate, maybe there are some company like Axon building some like SDK which allow you to translate access data from other chains. So maybe that can build some kind of interoperability. But I don't think like you share sequencer, prover, or share whatever, unless you have some strong economic assumption, you can't do that. It's a problem.
So our CTO Greg Dawes recently figured out the idea, but it's just an idea, but not the implementation yet. So the idea is to allow the L1 validator to have an in-protocol commitment about like proposing 2 blocks, one for Tycho, the other one from, for example, ZK-Sync, all together, and at the same time guarantee that one transaction in Tycho's block and the other transaction on ZK-Sync's block must happen together to have this kind of like an in-protocol commitment, so that I can transfer my token to Alex on my chain, and Alex must transfer some token to me on his block. But this is not so easy to implement. But in theory, we can do that. We can have kind of like this cross-layer 2 protocol to ensure like atomic transitions, like inter-chain app. I think it's a fancy idea, but it takes time to implement.
Interesting. Yeah, I think interchain app is really interesting idea, and I look forward to seeing more and more interchain or integration between the ZK layer tools. And so for the next session, let's discuss about your potential competitors, especially ZK VMs projects. Recently, we have seen projects like Wisio integrating REVM to generate pools for on-chain data. And from a use case perspective, projects like ZKVM seem to support more generalized computation and even allow direct integration with common high-level languages. So what do you think about these new kinds of ZKVM and also like potential ZK ARMs? And do you think that these are going to be your challenges? How do you think about that? We're going to go first. Alex.
Oh, sure. So yeah, as I said before, I think we'll all converge technologically on the working engines. We will have the most efficient virtual machine for provability and zero knowledge proofs, and then this underlying machine will be able to execute different virtual environments. It could be EVM, it could be RISC, it could be ARM, whatever. So in the end, we'll be able to just run EVM, but also connect programs written in higher performance, higher accessibility languages across and natively interoperate. So this is something that's coming, and you better embrace it sooner than later.
Awesome.
Yes, this technology is very exciting, we've heard. It's something we are also being involved in researching on this topic because it's very, let's say, promising. But I think as of today, we need to be trying to provide the best context integration of solutions to the users of our networks. Best entering life cycles for these technologies, and we were discussing before about acceleration performance. So as of today, we need to be trying to provide what's best available. And of course, looking forward to what's next evolution, next to come, because we discussed that potentially there's also, Alex discussed, there's potential convergence in the long term. We are in this research phase of exploration. We still don't know what's going to be the best, if even our teams are researching. So we have different generations of provers coming. So we need to be open to any potential disruptive innovation on this sense, because security is just starting. But it's more than a threat. I think it's an opportunity for them. It's something that we are willing to explore and to see what's the potential benefit for users and potential benefit for us also, because maintenance of proofs is something that's heavy. Once you are in production, you realize that, touching networks and creating networks is kind of a big deal. And all of these benefits from such a technology will be, overcome and be beneficial for everyone. Also in terms of security. But we need to see what's the actual status of these solutions in terms of performance. But super exciting.
So I was quite shocked when I saw the blog from RISC-0. Like 2 years ago, I didn't even imagine this is even possible, and doing something within a few hours without writing any circuits. That's amazing, and nobody really enjoys writing circuits. When we hire people, they not only need to be able to write circuits, they have to understand our product design. What the Patricia's tree is, what's the key tag, right? So it's not the easy job to find the right circuit engineers. So with ZKVM, I think we can separate the two roles. Someone can just focus on the underlying proving system, and the other engineer can just focus on the protocol design, right? So I think it's the future, to be honest. But it will take some time to verify all the existing offerings. I mean, for example, RISC-0 still has something to open source. So for us, we want to make sure everything is open source. We build on open source stack. But yeah, I mean, I don't want REST circuits, to be honest. So I think that's the future.
For us, our current priority is always EVM, because as I mentioned previously, at the layer 2, you need to experience block space. That's your first priority, not just without solving some problems with your EVM, you kind of keep looking for new fancy features. And also if you develop EVM, as I mentioned, they already with zeros can already deploy on Strobe. And for me, EVM, the performance still something we need to look at, because as far as I know, RISC-0 proving this kind of gas takes one prover takes 64 GPUs, which means you for your 2000 machine there can only be at most 30 provers. So the performance still needs to be massively improved. Even if you have something like a general purpose virtual machine, you still need to write CAD and all those kinds of circuits for really crucial part, because EVM is such a special system. And also you need to trust the compiler, trust the virtual machine. I think we had to write something in case blog post long time ago about the path they haven't taken about when they start their EVM, there are other virtual machines, but it's still true to EVM because for when you have time diversity, when you have different implementations, it's easier for you to align on EVM spec instead of relying on some more complicated compilers, some more complicated instruction set, and all those stuff. So I think for security reasons, for a lot of reasons, I think our current focus will still be EVM, but we look for more breakthroughs for the EVM, and maybe how to control, maybe add some output to the EVM to kind of call the EVM and the Oracle and the verify proofs. I don't know, there are a lot of possibilities, but it depends on your current focus. We also want to embrace the safeguard of our ecosystem, which means we encourage everyone to try and build something on top of us, instead of we are kind of just doing this.
I think as Polyhedra, currently we are branding ourselves as an interoperability solution, but at the core it's more we are relying on our new proof system. So we are building a proof system. And for ZKVMs, they are more like building VM circuits on the proof system or compiler on this proof system. So we can collaborate. We are open to collaborate with them, and our proof system can speed up their ZKVM, and their ZKVM can help us to reach more users. So this is a win-win solution for Polyhedra and for RISC-0 or ZKR. So yeah.
Yeah, I'll make it very short. I think from our perspective is, how to acquire a user or how to acquire a developer, who actually how to use ZK to achieve some new feature in the application level. And like the reason we focus on EVM is because we find more than 95 developer, like 95% of the dApps are building on EVM. But there's only one one and a half I think projects besides EVM success is like Solana and maybe Cosmos. So that's what I'm thinking. But in general, there's definitely great ZKVM, I think, like Starkware and even Aspen, they can use ZK to achieve some new features with their own language. But from our perspective, we are more thinking of how to enable Solidity developer, build some new applications using ZK, and they just call our contracts and execute this feature and make more interoperability.
All right. Yeah, for the next question, let's talk about the developers community. And we know that ZK is a really hardcore technology, and actually there are very few engineers around the world can write about ZKs. So what do you think that we can solve about this challenge? There's a lack of learning resources, and especially regarding to the the early stage developers, and how we can build and extend the developer community in ZKs.
I think there are existing communities like the ZK Study Club and multiple others who are focusing on early entry-level developers in the ZK space specifically. But as I said before, I think that most people will not need to bother with zero knowledge to specifics and with math and cryptography. People will just using high-level abstraction. When you work with GPUs, you don't do it usually like low-level images. Use high-level libraries that do some complex algorithms for you, and I think that's going to be the case here.
Meta languages like what? I think every time there are more ZK developers. I think it's not, as of today, it's very raw, it's very difficult to understand, but there are so many smart people in the world, and it's very exciting field of research and to explore. And there's a lot of people approaching. Probably happens to the office projects now. Approaching, I want to learn, I want to be part of this team, I want to grow in this field. So there's this tension between we need to have more nativity and better documentation, better resources for developers, but also the mystery about the ZK, that's something that's kind of exclusive. If you become a developer here, you will be very successful. So it's at this point, every time I see more projects and I see more resources, more developers. So we need to do better to get into the space of ZK apps probably, but the ZK protocols, I think we're doing pretty good. Also, everything is open source. So documentation is not, perfect, but at this point you can find fairly enough of all the documentation. But yeah, we need to do more. Our focus today is basically. But of course, if we could have better pool of developers, it would be probably faster.
So it's quite challenging to find the right people to write circuits, and we feel like we need to contribute back to the community by giving grants to people who can, share ZK experience, writing, tutorials, etc. The type of team trying to learn from open source software and from our peers, and we are lucky to be able to learn from other ZK rollouts. We share code base with Ethereum Foundation, the TSC group, and also contribute a lot to the repository, and a lot of code we are also using. So we are very grateful that we have those resources that we can use. Otherwise, it's not impossible to build a tech at all. So we learn from the open community. We need to contribute back. So that's our attitude. And we really look forward to further collaborate with other layer tools. Maybe we can build up some community. Collaborate on content. we are trying to create a lot of videos to teach people how to write circuits, but we really haven't we have just decided we're not really started. So maybe we can work together, one team is still too weak. Maybe it takes, the multiple teams to get this done.
Yeah, for us, being open source, being community driven is always our important values. And I think that really helps Zk innovation because initially we are using Halo 2 stack. Initially it's only Zcash using that, and then later PSE team, us, a lot of teams start using that and developing more toolings library on top of that, start optimize that. We have some GPU implementation for that, and people are building some better front end DSL on top of that. So it's really powered by the community, and especially a lot of projects when they are sharing the same effort, it really makes things easier. For the last year, we have done numerous workshops, lessons, lectures to different universities and different places around the world, access to kind of teach people how to build. I think only you have a large base, who are interested in your stack, who really believe in open source value, really want to kind of build with community, that will really be powerful. And also, we are doing some effort for Halo 2 community edition, and there are some amazing people actually from community build Fry Verifier in that repo, which is very unexpected and very surprising for even by us. So that's really trying for us. So I think for every tooling, every log might have built their own server, but I also believe that having some shared standard and having something shared and more modularized will be beneficial for the whole ecosystem because you build some gadget and other people can reuse it. It's not only improve their efficiency, you don't need to write that gadget, but also improve the shared security because other people might support some bugs. So I think that's the path I want to go. But eventually, maybe AKVM can be helpful on this front because if you really build all the kind of complex stuff, at home and then other people are hidden from the details, maybe that's beneficial, but that's still takes a quite long time. Before that, being open source, being community driven is the better way, more result and efficient.
Okay, good. Yeah. For concern of time, let's skip to the last question. Actually, I want to thank CKC and Taiko. We have been hosting 2 months CK Hackathon for 2 months and co-hosted by CKC and Taiko and Polyhedra. We have 500 CK hackers around the world attending, and 30% of these hackers are PhDs. And we have mentors from CKC, Taiko, Scroll, and Polyhedra. I think it's really important for these new CK engineers. And we can do something together, like Daniel said, to build a community together to bring more and more CK engineers in this industry. Yeah, so let's jump into the final questions, which is about the future of CK. So, yeah, we have seen that a lot of theoretical developments in the CK technology, including concept of coding, recursive proof, and more. So how do you foresee the future of ZK in the next 1 or 2 years? And also one last question about is, if you want to say something to the ZK engineer in Asia and in Singapore, what do you want to say to them? Yeah, the 2 questions. First question about the future of ZK. The second question is, what do you want to say to the engineers and the developers community in Asia?
So I think the future of ZK, I see that we're out of time in Signal, but so short answer, the future is bright, and yeah, exciting.
Yes, I agree. We are just starting. We need to, for the developers, the message is, guys, let's work on this because this is an amazing tech. It's just the beginning, and the future is amazing.
I think the future will be no circuit writing for most people, even roll-ups. And we will see multiple proving systems that will be able to prove the very same target your program.
I think we will settle down very few choices on proof system which are super performant and have proven security. Because currently there are so many directions, folding, small field, all those kind of directions, Virgo, all those directions. So I really want to settle down on some proof system. We have to stop this kind of like Starbucks, Snark, finding, and also let people into right circuit to kind of really use ZK for their application, and it can embed to Solidity or whatever.
I think ZK will experience exponential growth in terms of scalability in the next few years, and yeah, this is also helpful to achieve low circuit writing. Because if you got enough performance, you don't need to care about the size of the circuit. And we would like to invite more compiler developers to come into the field and to look at our structure and develop more optimized compilers and here in ZK field. Yeah. So people can get rid of the circuit writing. It's like writing assembly language currently. It's very, it's not a good user experience.
Yeah, I mean, from my perspective, I think, I wish there will be more use case of, application using ZK besides, scaling solution. I mean, I think there are already perfect scaling solution from these projects, and they're doing an amazing job. But there can be a lot of other use cases. I mean, libraries, but also in attestation, in other privacy or all of these new potential use case. Maybe in the next 10 years, ZK can be the same thing AI. A lot of people have no idea about it, but they actually using that day to day. So that's something really amazing. Besides only focus on one area, and also for Asian developers, we really like to see more developer working on this, and also see more applications working on ZK. And tomorrow, actually, we have a ZK Day. We host that in Denver and in Paris before. It's our pleasure to have the DCD support us as well. And we are as one of the kind of early Asian founder working on ZK. I wish there will be more projects keep working on this area.
Perfect, thank you. Thank you guys for coming this kind of day. You guys have way more knowledge of ZK knowledge in Singapore. Thank you guys.